Hi, welcome to 6.3, Congruent Polygons and Circles. Remember, segments are not equal when they have the same measure, okay? They are congruent. That is the definition of congruency. And the symbol for congruent is like an equal sign with a little squiggly, and it's used for all congruent figures, not just segments and angles. So we can say two triangles are congruent, two circles are congruent. Okay, and that's the big key in this lesson is some notation. So that's what we're going to talk mostly about. Okay, so hopefully if I said, how do you know two circles are congruent, you would have to know they have congruent radii. Radii is plural for radius. Okay, so if you have two radius, you have radii. And if they're exactly the same measure, you have congruent circles. Congruent polygons are a little more complicated because they have three properties. The same number of sides, and then those corresponding sides are congruent and the corresponding angles are congruent. So we're going to concentrate mostly on triangles today, but we're going to talk a little bit about quadrilaterals. Okay, so I don't think in this chapter we're going to get much past that, but you just have to know no matter how many sides a polygon has, these three properties have to apply. Okay, so are triangle ABC and triangle DEF congruent? Well, it depends. The corresponding, they have the same number of sides, so we've already satisfied the first property. The second says, are the sides congruent and are the corresponding angles congruent? So we're saying that angle A and angle D are congruent, angle C and angle F are congruent, angle B and angle E are congruent. Now just look at just that information alone. When we write the notation, do you see ABC corresponds with DEF in the notation? So when I say triangle ABC and triangle DEF, each angle, angle A corresponds with angle D, and the ABCB corresponds with E, angle C corresponds with F, in that order. Okay, order matters here. If I were to mix up DEF and say triangle EFD, that would be a false statement. They would not be congruent. Okay, and then also the corresponding sides. So BC is congruent to FE. EF. That matches the order that we have the triangle lettered. So ABC, BC is congruent to EF. So without even looking, we can see up here at the triangle. The next one would be side AB is going to be congruent to DE. Okay, and then the last is AC is going to be congruent to DF. Therefore, they are congruent. Okay, so given these two triangles, what conclusion can we draw? I want you to go ahead and write an answer down before I show you the answer. The question is, segment AB is congruent to what? 1, 2, 3, or 4? If you said 2, you are correct. Now, we don't even have to draw these figures to know that. That's what I was trying to get at on the previous slide. AB is going to be congruent to XY without even looking at the figures, because you know those triangles are labeled appropriately. Same thing with this one. If angle B is going to be congruent to which thing? 1, 2, or 3? If you said 2, you are correct. Angle Y is the middle angle in our labeling, just like B is the middle angle in our labeling. Okay, so if I rearrange the letters, so instead of saying ABC, I'm saying triangle CBA, how would I match the congruency in the notation there? So go ahead and write and see what you think. If you said ZYX, you are correct. Now this one, the figure is much more helpful because you can match up C with Z and B with Y as far as angles go, and then A with X. again, I'm just rearranging the letters. Which one do you think it is? If you said XZY, you are correct. Okay, so another definition for you is just congruent triangles specifically. Okay, although congruent triangles does fit the congruent polygon definition, congruent triangles, you already know they have the same number of sides. So this definition is a little bit redundant, where triangles mean they have 3 sides, so they have to have corresponding angles and corresponding sides. There's really nothing different about this definition than the definition of congruent polygons. We're just labeling the sides ahead of time. And then we have our theorems. Okay, so triangle congruence is an equivalence relation, and just to review, an equivalence relation is a relation that is reflexive, symmetric, and transitive. And really, if I haven't repeated that enough, you need to write that down. Circle congruence is an equivalence relation. So what does that mean? I hope you know. Reflexive, symmetric, and transitive. Polygon congruence is also an equivalence relation. And our last slide is our whisk summary. So I just want answers as complete as you can give me for these. For number 1, it can just be probably just going to be a sentence for you, but for number 2, the notation is super important. Okay, so if circle A is congruent to circle B, what do you know? And if quadrilaterals ABCD and quadrilateral PQRS are congruent, list all the possible conclusions. Okay? All right. So I will get that email. See you in class.